Guys, this is Mr. Millings, and in this video we are going to learn how to predict the products of single replacement reactions using a reactivity table. So in an earlier video we learned about the different types of redox reactions. We learned about synthesis reactions and decomposition reactions and double replacement reactions and combustion reactions, and last but not least we talked about single replacement reactions as being one type of redox reaction, a reaction in which the transfer of electrons is the primary driving force behind those reactions taking place. And in this video what we're going to do is we are going to learn how to start predicting the products of single replacement reactions, and when we do that we have to have out what is called a reactivity table, and we'll talk about this in a second. But if you remember from an earlier video when we talked about single replacement reactions, we said that they generally look like this right here, that you have some sort of compound consisting of a positive ion bonded to a negative ion reacting with some sort of element right here. And what ends up happening is that Y and A are going to end up swapping places. They're going to end up trading spots. Why is that? Because what ends up happening here is that Y is going to transfer an electron to A, and when that happens, A becomes neutral and Y becomes more positive since it lost an electron. And when we see this happen, right, when we see the positive ion swapping out, it's because Y here is going to be some type of metal. It's going to be some sort of metal from the periodic table. All right, so that's one type of single replacement reaction. And another type of single replacement reaction, Y here is going to be a halogen from group 17. And what ends up happening is that Y and X are going to end up swapping places. Okay, so Y and X are going to end up swapping places because X is going to transfer one of its electrons to Y. So one little electron is going to be transferred to Y here, and when that happens, Y becomes more negative and it ends up bonding to A, and because X loses an electron, it becomes more positive and ends up being completely neutral over here with no charge at all. All right, so those are the two different types of single replacement reactions. And typically right here, this will end up being a halogen, or it could end up being some sort of metal from the periodic table. All right, so if we use our reactivity series over here, here's how it works. It basically says to determine whether a given single replacement reaction will occur, you must use a reactivity table. And it says if the metal or the halogen is above the element it will replace based on the reactivity series, a single replacement reaction will occur, assuming the chemical reaction takes place in solution. So if we take a look right here, it's important to keep in mind that metals are going to replace metals and halogens end up replacing halogens. So if we take a look at this example right here, we have some sort of ionic compound, sodium bromide, reacting with chlorine, which is a halogen, right? So we have a halogen here, we have a halogen here, so we want to know, are these two going to end up switching places? Well, to figure that out, we have to look at our reactivity series. And if chlorine is above bromine, the halogen that's in the compound, then yes, they will end up switching places, right? So is chlorine above bromine? It is in fact above. So what ends up happening, these are going to end up switching places, and you're going to end up with bromine plus sodium chloride. And here's your balanced chemical equation for that reaction. If we take a look at this example here, we have a metal, right, reacting with some sort of ionic compound, and so we want to know, hey, is this metal going to end up switching places with this metal? The way that we figure that out is by looking at our reactivity series. And if we take a look, what we need to figure out is if copper is above aluminum on our reactivity series. And so if we take a look here, here is copper. Copper is right here. And we'll see that the metal that is in the compound is aluminum, which is way up here. So because copper is below aluminum, no reaction is going to end up taking place, right? So no reaction ends up taking place here since copper is below aluminum on our reactivity series. So that's how we can use this reactivity series to start predicting the products of single replacement reactions. So let's take a look at a few examples. Let's go through some together, and then you'll try some of your own at the very end of the video. All right, so in these examples it says to determine whether or not a chemical reaction will take place in solution. If so, predict the products. If not, write no reaction to the right of the arrow. So we have a reaction here, or a possible reaction taking place. Iron, looks like iron 2 oxide plus sodium. So what we have to figure out is, well, let's take a look. We have a metal here, so we want to figure out is if this metal is going to replace this metal right here. So what we have to do is we have to take a look at our reactivity series, and if sodium is above iron, then yes, a chemical reaction will take place. Here is sodium right here. Here is iron right here. So yes, a chemical reaction is going to take place here, right? And so what we have to do now is write the products of this chemical reaction. And so if these two guys are going to end up switching out, we will end up with sodium, which has a +1 charge, bonding with oxygen or oxide, which has a 2- charge. And so if you remember from an earlier video, you're going to end up needing 2 of these sodiums to cancel out the -2 charge of oxygen here. And then we're going to end up with iron, which will have no charge at all, right? It's going to have no charge at all anymore, because what's end up happening is that the iron atom here ends up gaining an electron from sodium over here. All right, so yeah, a single replacement reaction will occur. We're not going to balance these chemical equations. We can just leave them unbalanced, but there you go. There's the chemical reaction that's going to take place. Iron 2 oxide is going to react with sodium to produce sodium oxide and iron metal. Let's take a look at this one. Will a chemical reaction take place? We have bromine here, which is a halogen, so we want to know, is bromine going to replace this halogen? Well, let's take a look. Is bromine above chlorine on our reactivity series? No, it is not. So will a chemical reaction take place right here? No reaction is going to take place in this example. Let's take a look at this one. Sodium bromide reacting with iodine. So what we have to figure out is if this halogen here is going to replace this halogen. Remember that in single replacement reactions, metals replace metals and halogens replace halogens. So if I2 is above Br, or if iodine is above bromine or bromide on our halogen list, then yes, it will be replaced. Iodine is right here. Bromine is above it. So will a chemical reaction take place here? No reaction is going to end up taking place here either. Let's take a look at this example right here. We have silver chloride reacting with copper metal. So will a chemical reaction take place? Well, if copper is above silver on our metals list on the reactivity series, then absolutely. So here is copper right here. Silver is right below it. So copper is above it. And so we're going to end up having copper 1 chloride plus silver metal as our 2 products of this single replacement reaction. Let's take a look at this one. We have aluminum nitride reacting with iron metal. Let's find out if a chemical reaction is going to take place here. Is iron above aluminum? Here is iron right here. Aluminum is above it, so no, reaction will not end up taking place here. So no reaction is going to take place here. Let's take a look at this last example right here. We have barium reacting with aluminum oxide. Will a chemical reaction take place here? Well, if barium is above aluminum on our reactivity series, then yes, a chemical reaction will take place. Here is barium, aluminum is down here. So a chemical reaction will take place. These two metals are going to end up swapping out, and you're going to end up having aluminum metal with no charge at all, and barium oxide. Now we know barium is a 2+ charge, we know oxide is a 2- charge, so these two charges are going to add up to 0, and we don't need to include any subscripts in our chemical formula. Alright, so yeah, barium reacting with aluminum oxide is going to produce aluminum and barium oxide. Alright, so that's how we can start to predict the products of single replacement reactions using our reactivity series. And keep in mind as well that whenever you have any one of these halogens, well, fluorine, chlorine, bromine, and iodine, they are all diatomic molecules. They're diatomic molecules. What does that mean? Well, if you remember from an earlier video, we talked about this, that if they're not bonded to another atom on the periodic table of elements, they will always be bonded to themselves and form diatomic molecules. Okay, so for example, fluorine, when it's not bonded to another element on the periodic table, it will always be bonded to itself and form a diatomic molecule. Same thing with chlorine, same thing with bromine, and same thing with iodine. Okay, so keep that in mind when you're writing these chemical reactions and predicting the products, that these right here, when they're not bonded to another element on the periodic table, they're going to have to be bonded to themselves. All right, okay, let's try some on your own. All right, what I would do at this point is pause the video and try these on your own. So you have to predict whether a chemical reaction is going to take place here. Same thing right here, same thing right here. In fact, predict whether a single replacement reaction is going to occur. And if a reaction will occur, go ahead and write the products of the single replacement reaction. And I'm going to give you the answers right about now. So how did you guys do? Did you get them all right? If so, then you're pretty good at predicting the products of single replacement reactions. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that's going to subscribe you to my channel. And feel free to leave any comments in the comment section down below. And I really hope you guys found this helpful.